Okay, this is concept 40, so please title it on top. Don't forget to write your name as well. So what is trigonometry? Trigonometry is the study of triangle measurement. And we're not new to this because we've been doing triangle measurement for a long time, right? When we were doing Pythagorean theorem, we were working with isosceles triangles and similar triangles. However, trig ratios are specific to being able to solve all the sides and angles of a triangle. My trig ratios are sine, cosine, and tangent. So the sine, the ratio of the leg opposite the angle to the hypotenuse. So sine of A, here's A. Sine is opposite over hypotenuse. So from angle A, opposite side would be little a. The hypotenuse, of course, is always going to be opposite the right angle. So little c. So sine of A, opposite little a over c. If I'm looking at it from the perspective of angle B, I have little b over hypotenuse c. So opposite over hypotenuse. So down here, sine, you can abbreviate opposite over hypotenuse. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So if I'm looking at angle A here, what side is next to angle A that is not the hypotenuse? That's going to be side B. Side B is next to angle A that is not the hypotenuse. So adjacent over hypotenuse, B over C. If you're looking at it from angle B, what's adjacent to angle B? Little a, so little a over C. Tangent will be the ratio of the leg opposite the angle to the leg adjacent to the angle. So tangent of A, here I am in angle A, so opposite over adjacent, opposite little a, adjacent little b, so A over B. The tangent of angle B, here's angle B, okay, so opposite over adjacent, little b over A, so little b over A. So to finish here, cosine again was adjacent over hypotenuse, so you can abbreviate ADJ over HYP, adjacent over hypotenuse. And then tangent, we said, was opposite over adjacent, so opposite over adjacent. And there's this mnemonic device we use to help us remember. It's called SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So looking at this first triangle here, it's a right triangle, sine of A, here's angle A. So what's opposite to angle A and what's the hypotenuse? The hypotenuse, again, is always going to be opposite the right angle, so 13. So sine of A is 5 over 13. Cosine of A will be adjacent over hypotenuse. So again, not the hypotenuse, that's going to be side 12, so 12 over 13. Tangent of A, so here's A, opposite over adjacent, opposite is 5, adjacent is 12, so this is 5 over 12. So notice that the tangent does not use the hypotenuse, right? So it's 5 over 12. Sine of C, here's C, okay, opposite over hypotenuse, so 12 over 13. And then cosine of C is adjacent over hypotenuse, so what side is next to angle C that is not the hypotenuse? That's going to be 5, so 5 over 13. Tangent of C is opposite over adjacent, so what's opposite to angle C? I have 12, adjacent is 5, so 12 over 5. And that's it. We just listed all the ratios. For number 2 is asking for the same thing, but we're missing the hypotenuse. So to find the hypotenuse, we got to use the Pythagorean theorem. So 9 squared plus 12 squared equals c squared. You're going to get 81 plus 144. That's equal to c squared. And then this is equal to 225 to 25, and then you would take the square root of both sides, and you're going to get that c is equal to 15. So this side here is 15. Now we do the same thing. Sine of w, opposite over hypotenuse, 12 over 15. Cosine w, adjacent over hypotenuse, 9 over 15. Tangent of w, opposite over adjacent, 12 over 9. Now we're looking at angle x. Sine of x, opposite over hypotenuse, 9 over 15. Cosine of x, adjacent over hypotenuse, of 12 over 15. Tangent of x, opposite over adjacent, so 9 over 12. Now we have one more step, and that is, if you look at our ratios that we listed, we can definitely simplify these. So I have 4 over 5. I have 3 over 5. I have 4 over 3. Here I'm going to have 3 over 5, 4 over 5, and 3 over 4. A pattern that I want you guys to pick up, because it makes checking your work easy, is look at sine of w and then cosine of the opposite angle. They're going to be equal. And then same thing, cosine of w with the sine of the other angle. Those are also going to be equal. And then tangent of each angle will be the reciprocal of each. So this is an easy trick to being able to see what each angle is. For number 3, same thing. I do have to use a Pythagorean theorem, but this time the hypotenuse is given. So then I have to work to find b. So I have 16 squared plus b squared is equal to 34 squared. 16 squared is 256 plus b squared is equal to 34 squared, which is 1156. I subtract 256 from both sides. I'm going to get that b squared is equal to 900, and when I take the square root here, you're going to get that b is equal to 30. So the other leg of the triangle here is 30. So now you can take the trig ratio, sine of L, opposite over hypotenuse, 30 over 34. And I'm going to go ahead and simplify these already. I can divide top and bottom by 2, so I get 15 over 17. Cosine of L, here's L, so adjacent over hypotenuse, 16 over 34. And this is one I can simplify as well, so I get 8 over 17. Divided top and bottom by 2 there. Tangent of L, opposite over adjacent, so 30 over 16. And I can divide this by 2 as well, so I can simplify to 15 over 8. For sine of M, so here's angle M, opposite over hypotenuse, I get 16 over 34, which is equal to 8 over 17. Cosine of M, so adjacent over hypotenuse, 30 over 34. And this is 15 over 17. And then tangent of M, opposite over adjacent, so 16 over 30. And that's equal to 8 over 15. And then again, just double check. Look, 15, 17, 15, 17, right? The sine, cosine of the opposite angles there. And then same thing with M, L, cosine to sine, 8 over 17, 8 over 17. So these are right. Tangent is 15 over 8, and right here, tangent of the other angle will be 8 over 15. So it checks out. And that's all there is to listing side ratios in Concept 40.